Alright, these are word problems that are geared towards the rational equations and the rational expressions and equations that we've been working on. And so let's take a look at this first problem. Ryan can dig a hole that's 10 foot by 10 foot in 5 hours. So it takes him 5 hours to dig that hole. Castell can dig the same hole in 6 hours. How long would it take them to work together? One of the equations, and I'm not particularly fond of it, is work equals rate times time. And the reason I'm not particularly fond of it is I'm never impressed with what the heck is work in terms of how do you measure work. And the key is is that work is how many of those jobs did you do. For example, in this case, we're digging a hole, so that would be considered one job. If we dug 2 holes, we would have done 2 jobs. This will make a little bit more sense in terms of this. If I look at Ryan's rate of digging his hole or doing his job, Ryan can dig 1 hole in 5 hours. So therefore, if I took it times 5 hours for the time, just as an example, I could see 5s would cancel in that, and I'd get the work he's done is 1 hole. So that's what he's dug. He's completed that job. If I'd have plugged in 10 hours, he would have dug 2 holes. So that measurement, that work measurement, is in terms of how many of that job did you do. Now, once you kind of understand that a little bit, also understand what this rate means. And we just saw it there. In this case, Ryan, he can dig 1 hole in 5 hours. So that is his rate of work. And we've got Castell. He can dig 1 hole. Let's see if I get my unit up there where it belongs. 1 hole in 6 hours. Okay, so that's their rates of work. And kind of like speeds, if you think about an airplane flying along at some speed, 500 miles per hour, and it had a wind that was blowing along with it at 20 miles per hour, it would speed that airplane up to its airspeed, which would be 520 miles per hour. So the rates, miles per hour, just add. And so using that as kind of our analogy here, we want them to both be doing the same job at their own rates. And so we say, hey, Ryan does it at 1 job per 5 hours. We'll add on Chris, who does it at 1 job per 6 hours. And that will give us a total of 1 job per, well, I don't know. And that is what the question is asking. What is the time it takes for them to complete the job together? And so this is how it relates to our rational equations. Certainly we have an x or a variable in the denominator, so it's a rational expression or equation if we look at it all together. So now we can solve this thing. So we'd multiply by 30x, what would be the common denominator on both sides. When I distribute that, I get 30x over 5, 6x. I get 30x over 6, 5x. And the x's cancel on the right, just giving me 30. So 11x equals 30. And the rate, or the time it would take rather, for them both to do the job is 30 over 11. And I forget what decimal that is. It's 2 and 8 11, so 2.9 hours, something like that. Somewhere in that ballpark. So the key is to looking at their rate of work and adding them, subtracting them, or whatever the case may be. So I'm going to scroll down here a little bit. And now I'm on problem number 5 of the homework. Very similar problem. Paul and Daniel this time can pick 40 bushels of apples in 4.9 hours. So they can, if we think about what their job is, it's to pick 40 bushels in that amount of time. So Paul plus Dan, their rate of work together is 1 bushel, 40 bushels I guess, but we have to kind of group that job. So one group of 40 bushels, so 140 bushel pick, it takes them 4.95 hours. So in about 5 hours they pick 40 bushels. In 10 hours they'd pick 80 bushels, but they'd pick one group of that 40 bushels. And that says if Dan 9 hours by himself, so Dan can do that same job, one of those jobs, 40 bushels, in 9 hours. How long would it take Paul to work alone? And so we can write our equation like this: Dan's rate of work plus Paul's, and we don't know how long it takes him by himself, so we call that our x. The thing we don't know gives us a total rate of 4.95. Now, for this problem, I would not use our method of getting rid of rational expressions, just because trying to figure out what the common denominator for 9 and 4.95 is going to be a little bit awkward. So you can just get out your calculator, get a decimal value, and solve this for x at that point. And that would tell us the rate at which Paul could work by himself. Hopefully that will help you solve this.